Precalculus series. In this video, we are going to do how to subtract two complex numbers on the complex plane. Alrighty. Okay, so let's say that we have these two complex numbers, these two guys, Z and W, and we want to find out what is going to be Z minus W. Okay, so before we attempt this problem, first we will do what we did in the addition problem, parallelogram rule for subtraction of two complex numbers. So the rule that we did for addition, kind of a similar rule we have for subtraction as well. So parallelogram rule for subtraction of two complex numbers. Now, if you have been paying attention in your elementary school's math classes, then I'm going to explain one concept and you will understand it beautifully. Okay. See, if you want to do, I'm just going to write something. If you see there is 5 plus 2, it's something called 5 plus 2. We all know that is 7. Now, if you want to do 5 minus 2, we can also write it as, sorry about that. We can also write 5 minus 2 as 5 plus negative 2. So what I'm doing here is I am adding the additive inverse of 2, right? Additive inverse of 2 is negative 2. So this is again. So 5 minus 2 is nothing but 3. Similar concept we are going to use in subtraction of complex numbers. So let's say we have two complex numbers U and V. Okay, and we want to subtract them. That means we want to find out the value of U minus V. So we can write U minus V as U plus additive inverse of V, that is negative V. Right? Why we are doing this is because we know how to add two complex numbers, right? That's why we are changing subtraction. We're changing the problem of subtraction to the problem of addition. So instead of subtracting V from U, we are going to add negative V to U. Okay, this is going to give us the same result as U minus V. All right, so let's say that you have your complex number U somewhere here. This is your U. Okay, and somewhere here you have your second complex number V. Okay, and you want to find out what will be the value of U minus V. Okay, so first what we will do is we will plot negative of V. Okay, negative of V. So now here you just have to imagine something. What will be the segment connecting origin and V? It's going to look something like this. Line. Yeah. So this is your segment which will connect origin to V. And your negative V, see, you have not done vectors, but there is a concept called vectors. They are just, two-dimensional lines on graph papers. So this is V, and negative of V is just opposite of this line or opposite of this segment. For example, see, right now its direction is this. Okay, the direction of this line is this. So you will draw exactly same line in the opposite direction. Okay, and exactly of this length. Okay, so I'm going to do this. Draw exactly same line in the opposite direction. Just count how many units. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Extend it. Okay, it will be somewhere here. Actually, it will come here. Let me draw it again. Yeah. 1, 2, 3, 4, 5, 6. So this is your negative of V, negative V. This is your negative V. Now what you have to do is you have U and you have negative V. So first of all, let's connect U with the origin. Let's connect U with the origin. Okay. So you have two segments of your parallelogram with you. This is the first segment. This is the second segment. Now you can just complete the parallelogram. Let's do that. So if I try to draw a line parallel to this. Yeah. Okay. And then this guy. So this completes your parallelogram. And this guy is nothing but, you guessed it right, it's U plus negative of V or U minus V. I hope this was clear. So let's just come back to the problem. Okay, so first we will subtract these two complex numbers on complex plane, and then we will verify our answer arithmetically. So here in this problem, we want to find out the value of Z minus W. Okay, so I can write Z minus W as Z plus negative of W. Yeah, so I need to, first of all, I need to find out what will be the value of negative W. Okay, so first of all, let's connect Z and W with the origin. That will be your first step. Connect Z and W with the origin. I think this is very thick line. Let me make a thinner line. Okay. So this is your segment connecting to Z. Let's draw a segment connecting W. Okay. Now, this is your W. Now to draw negative W, we will extend this second segment so that the origin is halfway between W and negative W. Okay, so just see what I mean by that is I'm going to extend it like this. Okay, so you have to extend it such that your origin comes exactly between W and negative W. So you can just, count it. See here, it is 9 points above, 9 points above your real axis. So over here, it should be 9 points below your real axis. Okay. So this you have represented negative W. So let me just write it. So this is your negative W. So you have Z, you have negative W. Now you gotta complete this parallelogram over here. Over here. Okay. So let's do this. I'm gonna use the blue color. Okay. And add. This is the third segment. And now join these two to get the fourth one. Okay. So this is 0. This is your parallelogram, right? 0, Z, negative W. And then this vertex represents your Z minus W. Okay, this is the diagonal of this parallelogram. Now, what are the coordinates of this point? Looks like it is negative 10, and negative 7. This point. This is negative 10 and negative 7. Am I correct? Okay, so your final complex number is negative 10 minus 7i. So let's just verify this now. Let's come back to the basic background. Okay, let's verify our answer. So complex number Z, what is the value of Z? This was negative 6 plus 2i, and our W was 4 plus 9i, right? 4, 9i, and we want to find out the value of Z minus W. Okay, so basically we will get negative 6 plus 2i minus 4, minus 4 plus 9i, right? Okay. So we get negative 6 plus 2i. Apply the distributive property, we get negative 4 minus 9i. Collect the like terms, so negative 6 minus 4 plus 2i minus 9i. Negative 6 minus 4 is negative 10. 2i minus 9i is negative 7i. Oh, and whoa. What did we get graphically? We got the same thing, right? So this is how you subtract two complex numbers on complex plane.